Hello friends, welcome to this session of maths. Today we are going to look at rate and work. So the basic concepts of rate and work: if you are performing any job, rate is defined as the amount of job done with respect to a time. So we can say I am doing one third of a job per hour or half of the job per day. So when you multiply that rate with time, you get the amount of work done. So let's look at an example. A pipe fills a drum at 10 liters per minute. So it is liters per minute. So that is the rate of work. In 20 minutes, how much water will get deposited in the drum? So 20 minutes is the time, and work here is the amount of water that got deposited in the drum. So 10 liters per minute is the rate. You will see that rate is always with respect to time. So 10 liters per minute is the rate. Rate is always with respect to time. 20 minutes is the time, and 10 liters per minute into 20 minutes is going to give us 200 liters of water getting deposited. So this 200 liters is the work. Pay attention to units. If you look at the units of rate, it is liters per minute. Multiply that with minutes. So this minutes and minute will get cancelled, and you will see that liters per minute into minutes is going to give us liters. So always remember this: the units will have to be in such a way that liters per minute will have to get multiplied by minutes in order to get us liters. Another concept related to rate and work is time, speed, distance. So it's basically the same concept, wherein rate takes the form of speed and work takes the form of distance. So what we are basically saying is that we have some average speed. We travel with that average speed for a particular time, and in that time with this speed, this is how far we reach. That becomes the distance. So it's very similar to rate into time is equal to work. Let's see an example. A car runs at 20 miles per hour. So you will see that this is the rate, that means the speed part. In our daily life, we always say I was traveling at 80 kilometers per hour. So miles per hour or any distance per any time is speed. So this is the speed part. I am traveling for 2 hours. How far do I go? I go speed into time, that much far. So 20 miles per hour is the speed, 2 hours is the time. 20 miles per hour into 2 hours, I get 40 miles. So 40 miles is the distance. Again, pay attention to units. Miles per hour into hours is going to give us miles. So the only thing you have to remember is this formula: rate into time is equal to work. If it's time, speed and distance, this is time into speed is equal to distance. Average and relative rates or speeds, these are very frequently tested concepts on the GRE. So you will see that whenever they ask you about average speed, you just don't have to take the average of the given speeds. In fact, what you have to do is you have to take the total distance divided by the total time. So we know that speed into time is equal to distance, right? So that means speed is going to be distance divided by time. So we take the total distance divided by total time in order to find out the average speed. Relative speed: if two vehicles are traveling in the same direction, let's say for example, you are traveling in this direction in a car that is traveling at 40 kilometers per hour, and your friend is there in another car that is also traveling at 40 kilometers per hour. So will you see any difference? If you are sitting in one car, you will see that the other car is not moving. It's basically the relative the relative speed is going to be 0. And why is that 0? Whenever you both are traveling with the same speed, the relative speed is going to be 0. That is because you yourself are traveling at a particular speed and the other person is also traveling at the same speed. So you will see that there is not going to be any difference. So relative speed is going to be 0. Let's say for example your friend is traveling 50 kilometers per hour. He's traveling faster than you. So with respect to your car, his speed is going to be 50 minus 40, that is 10 kilometers per hour. If he's traveling slower than you, then it is, let's say if he's traveling at 30 kilometer per hour, then you're going to feel that he's traveling he's lagging behind, and you are traveling 40 minus 30, 10 kilometers per hour faster than he's traveling, right? So that is going to be the relative speed. So a few concepts here: SA plus SB, speed of A plus speed of B, in case both are traveling in opposite direction. Let's say if you're traveling 40 kilometers per hour this way, and another car is traveling 30 kilometers per hour this way. With respect to you, you're going to feel that this car is traveling 70 kilometers per hour. Why is this 70? Because you are going to add your own speed plus his speed, the other car's speed, in the opposite direction. So it becomes, with respect to you, it seems that the other car is traveling at 70 kilometers per hour in this direction. So you take you take sum of both speeds for opposite direction. You take the difference of both speeds when you are traveling in the same direction. These concepts will become clear to you when we go through the practice problems. So let's look at the first practice problem. Please pause the video and see if you can solve this. A person went to his office at an average speed of 40 kilometers per hour and returned at an average speed of 60 kilometers per hour. What was the average speed for this entire trip? So if you are doing average of 40 and 60, if you are doing this, then that is not going to be correct. We'll see why that is not going to be correct. So how we should go about this problem is like this. So let's say he's starting from here, it is his home here, it is his office here. The distance is d kilometers. We'll take the same unit, d kilometers. So from here, home to office, he goes with an average speed of 40 kilometers per hour, and returning he comes with 60 kilometers per hour. Okay, so what is this formula for average speed? Average speed is equal to total distance divided by total time. What is going to be the total distance in his journey from home to office and office to home? It is going to be d plus d is equal to 2d, right? D is the distance between home and office. What is going to be the total time? It is going to be the time taken for him to go from home to office, and then time taken from him to go from office to home. So that means time taken to travel d distance with 40 kilometers per hour plus time taken to travel d distance with 60 kilometers per hour while returning. Okay, so what is going to be the time 1? That means from home to office time. It is going to be, always remember this, speed is equal to distance by time. That means time is equal to distance by speed. So how much distance is he traveling? He is traveling d kilometers at a speed of 40 kilometers per hour. So this is the time taken by him, plus returning time is going to be d divided by 60. Correct? So that is going to be d by 40 plus d by 60 is going to be total time. 2d is the total distance. So average speed is going to be 2d divided by d by 40 plus d by 60. Let's simplify this. So what we get is 2d divided by, let's say we bring the denominator to 120. So we get 3d plus 2d. So average speed equal to 2d into 120 divided by 5d. So d and d get cancelled. 5 and 120 get cancelled. What do we get? We get 24. 24 into 2, we get 48. What is going to be the unit? Unit is going to be kilometers per hour. That is the average speed. So you will see that it is not correct to just take the average of 40 and 60. You have to follow this method in order to get the average speed. In this case, the average speed comes out to be 48 kilometers per hour. So let's look at this problem. You can pause the video and see if you can solve this. Jack ran along a rectangular garden. His speed alongside the shorter side was 20 kilometers per hour, and that alongside the longer side was 40 kilometers per hour. Okay, so we have a rectangular garden here. His speed along the shorter side was 20 kilometers per hour. This is 20 kilometers per hour, and along the longer side was 40 kilometers per hour. Here also 40 kilometers per hour. If the length to breadth ratio of the rectangle is 3:1, so that means this is 3x, this is the length, this is 3x, the breadth is x. Okay, find the overall average speed. Okay, so what is going to be the overall average speed? Overall average speed is going to be total distance divided by total time. So what is going to be the total distance in terms of x? It's going to be 3x plus x plus 3x plus x. That's basically the perimeter. So that is going to be 8x divided by total time. Total time is going to be time taken to travel this side plus time taken to travel this side plus time taken to travel this side plus time taken to travel this side. So what is that going to be? You will see that the time taken to travel length on both sides is going to be same because it's the same distance and the same speed, whereas time taken to travel the shorter sides individually is also going to be the same. So that means it is going to be 2 times. Let's first consider the length, time taken to travel the length individually, plus 2 times time taken to travel the breadth individually. So what is, let's come back to the basics. Speed is equal to distance by time, right? So time is going to be distance by speed. So all we need to do is to put relevant values for distance and speed here. So we already know the distance. Lengthwise, what is the distance? Lengthwise, the distance individual side length is 3x. The speed is 40 kilometers per hour. Here the breadth is x divided by 20 kilometers per hour, right? So we will see that ultimately you will get some expression from which x will get cancelled. So what do we have? We have 8x divided by, let's bring this to a common denominator. Let's say we are talking about 40 as the denominator. So we are, this remains the same. So what we get is 6x plus, here we'll have to multiply by 2, so we'll get 4x, correct? So that is going to be equal to 8x into 40 divided by 10x. So this x and x get cancelled. This 10 and 40 give you 4. So what we are talking about is 8 into 4, 32. 32 is the average speed. What is the speed? What are the units of speed? Kilometers per hour. So it's going to be 32 kilometers per hour is the average speed. Let's look at this problem now. Time spent along lengths to time spent along breadths, the ratio of that. So time spent along length, what is it going to be? It's going to be 3x divided by 40 is to x divided by 20, which is going to be 3x by 40 into x by 20, right? So this x and x get cancelled. What we get is this 20 and 40 give us 2, so we get 3:2. So time spent along length to time spent along breadth, the ratio is 3:2. Move to the third problem. I suggest you pause the video and see if you can solve this. Jack takes 1 hour less to reach his office when he increases his speed from 24 kilometers per hour to 30 kilometers per hour. Find the distance of the office and time taken to reach office at 30 miles per hour. Okay, sorry, this is not miles, this is kilometers. This is 40 kilometers per hour. Okay. So what information do we have? Takes 1 hour less to reach his office. So if he's traveling with this speed, let's say T1 is the time taken with 24 kilometers and T2 is the time taken with 30 kilometers. Now you will see that 24 kilometers, he is traveling at 24 kilometers per hour, he is going to take longer time, right? With 30 kilometers per hour he is going to take shorter time. So tt is going to be shorter, and the difference between t1 and t2 is 1 hour, so 1 hour less. So the equation becomes time taken to travel with 24 km per hour is time taken to travel with 30 km per hour plus 1 hour, and t1 and t2 both are in hours, right? And let's assume that the distance is he's traveling is d. So what equation do we get? t1 is equal to t2 plus 1. So what is t1? Distance by speed. Distance by speed is equal to t2, again distance by speed, plus 1, right? So let's solve this. D is going to be, what we'll get, we get one equation in D, and that the answer to that equation, when we solve that equation we are going to get the distance. So what we get is D by 24 is equal to D plus 30 by 30, right? That means 30D is equal to 24D plus 30 into 24, correct? So what we get is, let's get this on left side, 24D. So we get 6D is equal to 30 into 24. That means D is equal to 30 into 24 divided by 6. So 6 5s are 24. What we get is 6 5s are 30. What we get is 5 into 24, 120. So the distance from between his office and home is 120 kilometers. Okay, time taken to reach office at 30 kilometers per hour. So if the distance is 120 kilometers, time is going to be distance by speed is distance 120 kilometers, speed is 30 kilometers per hour. He is going to take 4 hours to go to office. Let's move to this problem. Please pause the video and see if you can solve this. A train 100 meters long is running at 20 miles per second, 20 meters per second in east to west direction. How long will it take to cross another train 200 meters long, 600 meters away and running west to east at 10 meters per second? Okay, now this is, you will see that there are two vehicles we are talking about. Both are traveling in same direction, opposite direction. Both have their own lengths, both have their own speeds. So it's a relative speed problem, right? So one train is 100 meter long. It is traveling at 20 meters per second from east to west. So it is going like this. The other train is here. The distance between the two trains is 600 meters. This train is 200 meters long. This train is 100 meters long. This train is 200 meters long and it is going from west to east at 10 meters per second. Now both the vehicles are traveling in different directions, so we'll have to add their speeds, right? So with respect to this speed, the original train, the new train, the train that is coming from the opposite direction is traveling at 10 plus 20, 30 meters per second. So 30 meters per second is the time that is the speed with which this train is moving, train B is moving with respect to train A. It is always important to consider one train as the main base train and evaluate all the equations with respect to the first train, right? So with respect to train A, train B is traveling at 30 meters per second, and how long will it take to cross this entire train, and before even crossing this train it will have to cross travel for 600 meters. So the total distance that this train has to cover is its own length plus the length of this train plus the distance in between, right? So that distance is going to be 900. Is going to be 100 plus 200 plus 600. So that is 900 distance it has to travel with an effective speed of 30 meters per second, because both are traveling in different directions, so their speeds will get added. So 900 meters divided by 30 meters per second is going to be 30 seconds. right? So answer to the first one is 30 seconds. Okay, let's look at the next one. Another train 200 meters long, 600 meters away, running east to west at 10 meters per second. Now this train is also going east to west, so that means the effective speed is going to be, will have to be subtracted. So with respect to train A, the effective speed of train B is 20 meters per second minus 10 meters per second. That is going to be, effective speed is going to be 10 meters per second. So again the same thing. How long will it will the original train take to cross this new train? It will have to travel the 600 meters, it will have to travel this 200 meters, it will also have to travel its own length. So that is again going to be 900 meters. 900 meters divided by 10 meters per second is going to be 90 seconds is the answer. Another stationary train. Okay, I'm sorry, there is a typo here. This is stationary. Another stationary train, 200 meters long, 600 meters away. Okay, now this new train is stationary. That means it has zero speed, right? So the effective speed is going to remain 20 meters second. That the effective speed is going to be the same speed, the speed of the original train, right? So that is 20 meters per second is the effective speed. How much distance does this train now has to cover? It has to cover its own length, that is 100 meters plus 600 meters plus the length of the third train, that is again 900. 100 plus 200 plus 600, 900. So 900 meters divided by 20 meters per second, so that we get 45 seconds. 45 seconds is the answer here. One pole 1 kilometer away. Now when we are talking about a pole, actually we are just talking about one particular point, so that means it doesn't have any length, breadth, so that means it's going to be 0. So all this train has to pass is its own length plus the distance between the pole and the train. So what is that distance? That is 1 kilometer, that means 1000 meters. So the train has to travel 1000 meters plus its own length divided by, pole is obviously stationary, so again effective speed is going to be the speed of the train. So speed of the train is 20 meters per second. So this answer is 1100 divided by 20, 1100 meter divided by 20 meters per second. So what we get is 55 seconds. So answer here is 55 seconds. Let's look at this problem. Please pause the video and see if you can solve this. It takes 8 hours for pump A used alone to fill a tank of water. So rate of pump A is going to be 1/8 of a tank, right? So in 1 hour 1/8 of the tank it gets filled by A. Similarly, rate of tank B is going to be 1/6 tank, right? Because it takes 6 hours for B to fill the tank. So rate of tank C, let's say it is C. So rate of C rate of C is 1/C. It takes C hours for pipe C to fill the tank. So rate of C becomes 1/C tank. Okay. And when all three are used together, that means RA plus RB plus RC, it takes them 2 hours to fill the tank. So this is the equation we get. This is the amount of tank that gets filled in 1 hour. We do it for 2 hours and we get the entire tank full, right? So let's put the values here. What we get is 1/8 plus 1/6 plus 1/C is equal to half, right? So what is this? This is 14 divided by 48 plus 1/C is equal to half. So half can also be written as 24/48, correct? So let's get 1/C on one side. 1/C is equal to 24/48 minus 14/48. So it is 10/48. So C becomes reciprocal of that, 48/10, 4.8. So it is 4.8 hours it takes pipe C to fill the tank. What should be the rate of pump C. So rate of pump C is going to be 1 by C, which is going to be 1 by 4.8. And how long will it take pump C used alone to fill the water tank? For pump C, it is going to take 4.8 hours for it to fill the tank. So let's look at this problem. Please pause the video and see if you can solve this. A boatman rows his boat in still water at an average speed of 20 miles per hour. Okay, so his speed in absolute water, absolute speed is going to be 20 miles per hour. Now pay attention here. So this is the speed when he rows in still water. That means water that is stationary. That is his absolute speed. Now if he is rowing in running water, so let's say water is running like this and he is rowing also in the same direction. Obviously he is going to row much faster, right? If the water is running at X miles per hour and he is traveling, he has a speed of 20 miles per hour. So effectively he will be traveling at 20 plus X miles per hour. On the other side, if the current is flowing like this, X miles per hour, and he has to row in the opposite direction with 20 miles per hour, his speed is going to get reduced. His speed is now going to be 20 minus X miles per hour. So this is the basic concept involved. We have to see whether we have to see in what direction he is traveling, right? And the speed of the current is given as 10 miles per hour. So the first question is, how long will he take to row 50 miles down the stream and come back? So he starts from here, he goes 50 miles down, he reaches this point and he comes back again, this way and this way. So how long does he take? So the time taken is going to be time taken to travel downstream and time taken to travel upstream. Okay, now we know the distance already. So all we need to find out is the speed, upstream speed and downstream speed. So the downstream speed, when he goes in the same direction as current, his speed is going to be 20 plus 10, right? 10 is the speed of the current, 20 is his own absolute speed. And when he is coming upstream, his speed is going to be 20 minus 10, which is 10 kilometers per hour. While going, it is 30 kilometers per hour, right? So now we have to find out total time. Total time is time taken for this journey plus time taken for this journey. So time taken for the downstream journey is going to be downstream distance divided by downstream speed plus upstream distance divided by upstream speed. So that is 5 by 3 plus 15 by 3. This is 5 can be written as 15 by 3. So we are talking about 20 by 3. What is going to be that? That is going to be how long. That means this is time. The unit is going to be hours. Pay attention to units. So the total time for this journey is going to be 20 by 3 hours. Let's look at the second question. How far will he be from the starting point if he rows down the stream for 2 hours and trails back the stream for another 2 hours? So he starts from here, goes down the stream for 2 hours, he reaches some point and he comes back. So obviously he is not going to reach this point. He is going to fall a little bit shorter. That is because he is rowing upstream, so his speed is going to be slow, so he will not be able to cover this much distance. So he is going to be somewhere here. We are interested in finding this distance because the question is how far will he be from the original point. So that is going to be distance covered downstream minus distance covered upstream. So distance covered downstream is going to be time into speed of downstream. Speed of downstream we already found out 30, and while coming back he travels for 2 hours again, and with the speed of upstream speed is 20. So what we get is 60 minus 40 is equal to, he is going to be, oh sorry, this is not 20, this is 10. So what we get is 60 minus 20 is equal to 40. It's going to be miles, 40 miles from the original point. So while going downstream in 2 hours he covers 60 miles distance, while coming upstream in 2 hours he covers only 20 miles distance, and this from the original point he is 40 miles away. Okay, let's look at this problem. Please pause the video. Lisa and Mary set out together on bicycle, traveling at 30 and 20 miles per hour respectively. So Lisa is traveling at 30 miles per hour and Mary is traveling at 20 miles per hour. Okay. After 45 minutes, Lisa takes a break. So let's find out at t is equal to 45 who has reached how far. So 45 minutes is actually 3/4 of the hour. So in 3/4 of the hour, Lisa would have gone 22.5 miles, right? Whereas Mary would have gone only 15 miles. Okay. After 45 minutes, Lisa takes a break for 1 hour, during which Mary continues to ride. So now at another point, 1 hour after, which is t is equal to 1.45, 1 hour and 45 minutes. What we get is Lisa is still there because she has been taking a break, whereas Mary would have gone in 1 hour. How far does Mary go? Mary goes 20 miles per hour. So that 20 miles plus this 15 miles earlier, so she is now at 35 miles. Correct? Now Mary continues. How long will it take? How long will it take Lisa to catch up with Mary? So now Lisa is falling behind. She is only 22.5 miles away, whereas Mary is 35 miles away. So let's say it takes Lisa. Lisa will definitely catch up with Mary because Lisa is riding faster, right? So let's say it takes her t time. So that means she starts with 20.5. Let's say from the original point, when she ultimately catches up with Mary, both would have traveled the same distance, right? And that distance is going to be 22.5 plus with a speed of 30, she travels for t time, whereas Mary is going to be 35 miles plus with a speed of 20, she's going to travel for t much time. Okay, so this is one equation with one variable. What we get is 10t is equal to 12.5, right? So t is equal to 1.25. Okay, so 1.25, it's going to be hour. So after 1.25 hours, Lisa is going to catch up with Mary, and the distance we can find out by putting value of t here in this side of the equation or that side of the equation. So now see if you can solve this particular problem. So a pool can be filled in 4 hours and drained in 5 hours. Okay. So that means there is one tap that fills the tank, and that fills the tank at 1/4 tank per hour, and there is a hole in the tank that drains the tank in 1/5 per hour. This is the rate, right? The valve that fills the pool was opened at 1 p.m. and sometime later the drain that emptied the pool was also opened. Okay, if the pool was filled by 11 p.m. and not earlier, when was the drain opened? So we have 5 options. Okay, let's see. So we have to find out the time when the drain was opened. So let's say that the drain was open for t much time, so t hours. The drain was open for t hours. Okay, and how long was the valve open? It was open for 11 p.m. minus 1 p.m. So it was open for 10 hours. So valve open for 10 hours. This is valve open for 10 hours, filling the tank and 1/4 per hour, 1/4 tank per hour, and the drain open for t hours and draining the tank at 1/5 tank per hour. Now we have this negative because it is draining, right? So when both these are active, what do we get? When both these are active, the tank gets filled up, right? It gets filled up at 11 p.m. but we have already considered the duration in here, right? So we don't have to worry about 11 p.m. now. So what we have is 10 hours into 1/4 minus t hours into 1/5 is equal to 1. Correct? So let's solve this now. What do we get? So we get 2.5, 10 by 4 is 2.5 minus t divided by 5 is equal to 1. So that means t divided by 5 is equal to 1.5. That means t is equal to 1.5 into 5, 7.5. So t is how long the the drain was open for. So the drain was open for 7.5 hours. So when was it opened? It was opened 7.5 hours before 11 p.m. So it was opened at 11 p.m. minus 7.5 hours. So that is going to be 3:30 p.m. Let's move to this problem. Please pause the video and see if you can solve this. 6 machines, each working at the same constant rate, together can complete a certain job in 12 days. Okay, so we have 6 machines, 1, 2, 3, 4, 5, 6, and they work for 12 days to finish a job. Let's say the job is X. So every day X by 12 of the job is getting done. X by 12 of the job every day, right? And how many machines are working every day? 6 machines. That means with respect to individual capacity, individual machine, X by 12 is the job 6 machines do. So X by 12 into 1 by 6 is the job every machine does every day, right? So this is one basic thing that we understood, that every machine works 6 by 12 into 6 does this much of job. Okay, now how many machines each working at the same constant rate will be needed to complete a job in 8 days? If you want to complete a job in 8 days, every day we need X by 8 job done. So we need X by 8 job done every day when every machine works for this much job. So how many machines will we use? We will need n machines. N machines into individual daily capacity of every machine is the daily job done, right? So we will see that X and X getting cancelled. What we get is n is equal to 12 into 6 divided by 8. So this is 2, this is 3, this is 3. So we get 9. So we need 9 machines for us to do the job in 8 days. So with that, I thank you for watching the video. I hope you learned a good deal about rate and work. I look forward to seeing you in the next class. Thank you.